Hello everyone, I am Harz Nawaz, and in today's video we are going to be talking about chemical bonding. Now, we're going to be going about the three types of bonding, which are ionic and covalent bonding. So in covalent bonding there are two types of covalent bonding, and that is polar covalent and non-polar covalent, and then we have ionic bonding. Now here I have images courtesy of Google, which will help me today, and I'll explain them, and images from my own Google Classroom, which help me as well. So before we get into bonds, we need to first talk about the importance of valence electrons in chemical bonding. Valence electrons are the outermost electrons in an atom. They determine how atoms bond with each other, and they also determine electronegativity. Means the ability to attract and bond with electrons. They are due elements want to follow the octet rule, which basically means all atoms want to have 8 valence electrons. Some of them have 1, some of them have 3, some have 7. So all of them want to hit 8, and they can do that through bonding. So the electronegativity decreases as the radius of the atom increases. So the more shells it has, the electronegativity decreases. Fluorine has the highest electronegativity. So if you can see the chart, going to the right increases and going to the top increases. So that's how electronegativity plays a role in bonding. It plays a very significant role and determines what type of bond it will get, such as an ionic bond. So what is an ionic bond? So ionic bond is the complete transfer of an electron from one atom, a metal, to another atom, a nonmetal. So it's the complete transfer of the electron from an atom to another. That doesn't mean they're sharing the electron. No. It's completely shared. For example, it has to be between a nonmetal and a metal. There are no exceptions for that. So we can have a demonstration right here with sodium and chlorine. So sodium has one valence electron right there on the outermost shell, and chlorine is one away from the octet rule. It only has 7, it needs one more. So through an ionic bond, chlorine is able to take that one valence electron, so it hits the octet rule, has 8 now, it's perfect, and sodium just loses that. So if it hits 0 as well, it fulfills the octet rule as well. However, atoms are more prone to get 8 valence electrons rather than just lose. Then we have polar covalent bonding, and so that's the unequal sharing of electrons. So the atoms bonding, they're similar but not identical and not too different. That means they both have to be non-metals. And so they have to be both non-metals. There's no exception for that. And they both are sharing the atom. So this is quite different from ionic bonding in the way they're sharing it, but one of the atoms is mainly using the valence electron. For example, here we have a demonstration. We have fluorine, which is also 7, and then we have hydrogen, which just has one valence electron. So fluorine is just going to share that one valence is going to take that valence electron from hydrogen, but hydrogen is going to use it less than fluorine is. So this is what polar covalent means. It's just one atom hogging that electron, but sometimes it lets the other atom use the electron as well. And now we have pure covalent bonding. Pretty much the easiest bonding to understand. We have a pure covalent bond has no ionic character at all. The electronegativities of both atoms are identical. In the bonding, electrons are evenly shared between both atoms. Basically, this means both atoms are exactly the same. This also means that both atoms are not confined to the rules of having to be a non-metal or a metal, and a non-metal and non-metal. This means that these atoms can be any atom as long as they are the same. Now remember that the electrons between these two atoms are equally shared. One atom is not hogging it because they both are the same, and one atom is not having using one electron less. They are both equally sharing it exactly at the same time. Now, an easy way to determine what type of bond you're looking at is to take both of the atoms you have, subtract their electronegativities from each other, and then use this right here to determine what bonds they are. Okay, so I just want to say thank you to all the viewers out there who watch this. Remember to go back in the video if you have any questions, or just ask in the comments below. Remember to also zoom in and just pause the video, because many of the charts and images will help as well. Please don't forget to like and subscribe. Thank you for watching the video.